Hello, my name is Gamaliel Medrano. I'm from Doctor's Risk class, section 2476-3. I'm going to be showing y'all homework 2 linked list. So let's get started. Alright, so we're going to read through this. The first part says, you will create a C++ program to add, remove, and sort objects in a linked list. The purpose of this homework is to get students familiar with linked lists and stuff. Okay, we already know. Okay, this is going to be adding, removing, sorting. Adding and removing is not that's hard. No, actually, sorry, remove is probably the hardest out of these three. Anyways, let's continue. The A input. Okay, the first line of the input file will tell you how to add data to your linked list. Alphabetically, length, beginning, ending. Okay. So we can see here that we're gonna have to be sorting for alphabetical order and length. Those right there, those are gonna be two functions right there. And then beginning and is pretty much just adding. It's just adding. That would be the adding. That would be adding function, and this would be the sort functions. So let's say alphabetical AZ and AZ capital come first. Okay. So we can see We'll be in alphabetical and length, short length, longest of the string. Okay, so it wants from shortest to longest, and it wants from A to Z. Okay, and beginning straightforward, add current string to the front of your list, and end add current string to the end of your list. The rest of the file, don't add empty lines or duplicate. Okay, this right here is very crucial. You do not want to add any empty lines or duplicate sentences. So no duplicates. Okay, we gotta take note for that. Next, we have the command file. Actually, let's start building a list first for this first part. Yes, for this first part, let's start with this. So I already have like sort of my list here. If y'all don't know how to make a list, I'm gonna show you right now. So first, we create a node, a structure to create just a node, nothing else, just a node. This is just basically the little pearls without the holes for the string to go in. So it doesn't link to each other. The actual list comes in the class where you actually link them together. These are just nodes that you want to store space and wait to see where you want to store it within the list. So first we have what type of storage data we want to store. In this case, we want to store a string because of the input file, and then we create a node that will point to the next node, and then we have a constructor to make our lives easier, so we don't have to keep repeating the same step over and over again. And then right here we have the constructor. So we're gonna have what? We're gonna have the line will equal the line, whatever the input, and then we're gonna have the next pointer point null because we're not pointing. This is not a list. Okay, so this is just a single node. This just creates a single node. That's right here is where we actually create the list. We want a head and we want a tail. Usually we only have a head, but we gotta add the tail because it asks us to add it to the end. That we're gonna need that later on. You'll see. The list size, I just have it because one of the TAs told me it's useful, but we won't use it that much because that's not how Dr. Risk wants us to do it. So okay. So we also, these are the functions we have. As you can see, we want to add it to the front, to the end, and we gotta check if it's empty. And we have one that sorts for the length and sorts for the alphabetical one. And I have another function that deletes the duplicate at the very end, so there'll be no duplicates. And then I have the remove function, which they told us, but we're not getting it right now. Right now we're just focusing on these right now. So let me see. So let's start for the constructor. So we have the constructor linked list. And then we're gonna have it to okay, we're gonna set head equals no PTR, and we're gonna have, that's pretty much it. That's pretty much it. We're not gonna look at the list size for today. And then we want to return because we're gonna be using the empty, because I'm pretty sure one of the test cases suggests if the thing is empty, we don't wanna input anything or something like that. So we always have to make sure we have empty function. Hold the scene. So bool English is empty, and we want to return is empty when head equals null. This will determine if the list is empty. And then we want to add it to the front. Okay. When we add a node to the front, let me just write this first. I'm sorry, I'm kind of slow typing today. Alright. So we're gonna have the parameter with the string, because this will be the piece of information that we want to add. Okay, when we add to the front, we want to create a new node. Every time we want to add something to the front of the list, we create a new node. So this is where the constructor is going to come in handy. So let's say we're going to have add new node is going to equal new, and then we're going to have the right here the type. This, if we didn't have the constructor, this is what it would have looked like. Add new node. But since we have a constructor, we can just put line 1, and we don't have to do extra steps like that. So right here we created our node. That we have our node right here. This our node exists. But now, since we're within the class, we want it to connect to the list. So this is where the is empty comes in clutch. So if the list is empty, we want the head to point to the new node. Okay, the head now equals the new node, so the head's address is now the new node's address. So that's because there was empty. So okay, so if it's not empty, we're gonna have new node next. Okay, so let's say the new node next. We want that to be pointing head. Okay, new node next. So next is actually the address of head. This allows it. So this is gonna look like. We're gonna have the new node now points to head like that. So now, but see the new node is in front of the head because the next equals to the address of head. But now we want to move the head back to the front so we can keep adding it for additional. So we're gonna have head now equals new node. See, we move the new node, the head back to in front of the new node, so that once we keep adding, this process will keep continuing. So it's going to be adding to the front, and the head will still remain in the front. Now this is pretty much it for the adding to the front, and now we took care add to the beginning. This is C. Now to the end, it's a little different. It's a little different. This is where the tail is gonna be involved. Okay, so almost the same thing. You have string, line, one, and then you also the same thing. We're gonna create a new node. We're gonna have new node equals new node line. So we create a node and everything, and we do. So now we check if it's empty. If it's empty, we want the head to equal the new node. But we want the tail to also equal the new node. Because the tail and head, since there's only one node after it's empty, then the head and tail will eventually be equal to each other since there's only one node. So they're pointing to the same because there's only one. But once you keep adding more, we're going to deal with the tail. So say else, if it's not empty, it's going to be different. We're going to have the tail. See, notice how we didn't use the new node this time? Because we're not adding to the front. We got to move the tail to the back. So tail next now equals head. And not head, scratch the not head, equals to new node. Okay, new node. And we want tail now equals new node. Okay, what we did here, we have head just stay at the first part. We just have head stay at the very beginning. But we keep moving tail. Over and over again. So head points to the new node. And then tail's next. So then the address after tail points to new node. I don't know if you can know what I'm talking about. But the tail moves to the back. It's gonna move to the back all the way here. So new node. So now we have tail moves here. So when we add another one next, it's gonna equal new node. And then we move the tail back to the end. And so on. That's how it adds to the end. See, it's different from, we don't move the actual head. We want the head to be the beginning, but we want the tail to be at the end so we can keep adding to the end. So that takes care of this end function. Now we want to sort alphabetically in length. Now this is actually their functions are almost the same. Almost the same. I say almost because they have something a little different. So I just have void link like this. Alpha sort, and we have. Okay. We don't have parameters because we're just changing we're not adding anything. We're just changing how the linked list is arranged. Okay. So this is what we're gonna do. We're gonna bubble sort this. If no one's familiar, with bubble sort, we're gonna go over this. So first, let's add a bool. Swap happens equals true. Okay, and then we want a node that will move along, because we don't want to alter with the head, because we need to move along the linked list. So we need cur equals head, and then we want also a previous node, because we want to track two nodes at the same time, but one has to be behind the other one. So a previous equals no. Okay. So at this point, if there's only one node, there will only current will only be declared, and previous will be no. So no, this vault doesn't exist if there's only one node. You'll see what I'm talking about later. Okay, so we're gonna create a loop to go through the list. This is what this part right here is gonna be useful. We don't use is empty right now because we're assuming that when we want to sort something, it's not empty. So this is not empty, because in the homework, like in the main, we're gonna do something that if the file is empty, so like the linked list is empty, we're not even gonna come through here. Like this is gonna, so that's what we're assuming. It won't be empty. So let's say while swap happens, so while it's true. Okay, so that's just so we can we declare this true just so we can freaking move into the loop at first, but we want to switch shit to false. Okay, we won't have solve false now because we gonna go into not another loop, but like something's gonna happen with the loop, because we're gonna swap, and when it swap, then you convert back to true. So if I started with false right here, it wouldn't even run, so we couldn't even start the loop. It will make no sense. So okay, so now we create another loop. That will actually, so this loop right here is actually what's gonna make the whole thing. Is gonna choose one node and compare it to everything else and like sort it. And if there's a swap, then it's gonna continue because so next. So we wanna stop when the next is not no. So that'll be the end of the list. So first, before we gotta have previous equals cur, right? Because we're moving through the list, and we want cur to now equals whatever's next. So cur next. Okay. Now, in a regular, so this method right here, we're gonna use this a lot through the other functions, because this allows us to just go through the linked list. This allows us to go through the linked list every time. So now we're gonna bubble sort like a regular array, but it's gonna we use the same concept, but since it's a linked list, we use different like that. We don't like in an array, we don't use this and stuff like that, but it's the same concept. So we're gonna have say if we're doing the alpha sort, so we're just gonna previous line. We're gonna see previous line is actually what the data. That's the data. And then if it's greater than current line, we want to swap it. See, you notice how we're comparing strings? Well, in C++, you can compare strings and like it's gonna like check if it's like. So this is what I was talking about. That's why C comes first. This is how C++ handles comparing strings anyways first. A automatically compares if it's alphabetical when we compare it. So if this is A and this is B, then A would be greater than B, and so on like that. I think that's how it goes, but it's still, yeah. So if A is greater than B, then A is greater, yeah. So A is greater, and so on. So this will, so let's say, I don't know, this is F and this is A. F is greater than A. No. Well, yes, so if this is greater than that, the previous one is greater than that, we're gonna want to swap it so we can have A. So let's say so D is greater than A. So we want A to switch with previous. So this data switch to this data. So this is what we're gonna do. I'm gonna copy because it's gonna be a lot of code, but I'm gonna explain it. So okay, I'm gonna copy from other homework. Okay, so this is what. Okay, I'm gonna explain this. Okay, this is really ugly. Let me see. Okay, let me explain. We cannot swap. We're gonna not actually use the swap function like we use with arrays. We're gonna have to use temporary. We're gonna use a temp. So right here we create a temp that equals to the previous address, and then we have previous now equals to the current address, and then so now the previous has the current address now, and then whatever was in the current now here. So it basically swaps everything. So for here I create a string temp which stores the data from current line, and then current line now has the right here has the data from previous line. So now previous line takes whatever was in current line because we use a temp. It's the same concept with the address. We have to change the addresses and everything. So that's why I copy and paste, because it would have been redundant to just keep going. So look, so we have the same concept. We have this next, we want it to beat the current next, so it can continue through the loop and have bubble sorted. So now we see that we have one swap has happened now. So we click true. But see, after we do this, the current, how will we have the current back to the head? We don't have it because this is not an actual array. So after we get out the freaking, after we get out the loop, we gotta set current back to head where it started, and we have to set previous back to null. Okay, that's what we created, because this has swap happened, so now it's true, and then it's gonna go true. Current goes back to head, and it starts all over, and it looks for the next null and list and so on. So it's gonna keep doing that. Now that takes care of alpha sort. So now this will be sorted alphabetically because we switch everything. We bubble sorted. So now it takes care of everything. Now length is literally almost the same thing, except it's the same thing. Yeah, it's the same thing, except here we just want to put the size of it instead of whatever, because the size will determine, because that's what I want. I want the shortest length of string and the longest. So we have to check is the size. It's really just the same thing as this, but we put dot size, and literally everything else will be the same because we're comparing the size of the string. So literally I just copy this and just put in that sort. Okay. So, and then just change this to the size of it, and then everything else will stay the same. It's the same concept. Because this is still, we're checking the size of the string, so we'll go from longest to shortest. If you want to put shortest to longest, you just change the signs. Same for this. If you want to go alphabetically downwards, just change the signs. Now we have taken care of this input file. We want to also delete. Okay, we look at this. We duplicate sentence. So we also create deleting duplicates. We have to create a deleted duplicate. Actually, let's add this to the second part of this, which is the hardest. This is the actual, okay. Command file will be filled with 3 types of command that will be run in order. They appear and add integers. Okay, we're gonna say add. It's gonna say int location string center. The add command will be followed by an integer inside parentheses and then followed by a sentence inside the bracket. If the location is bigger than the size of the list, then don't add it. If the sentence is a duplicate, don't add it. Add 0, this will be at the end. This will add to the beginning of your list. Add 3 example sentence. This will be added to the third index, meaning it will be 14 in your list. Okay, so basically this one just wants a location. It gives you a location and then you put that string. It's weird because it's going to follow like the array format. So like, you know how it doesn't go from 1 through, let's say the size is 5, it doesn't actually go from 1 through 5, it actually goes from 0 to 4. That's what this is targeting. That's why I said when you add to 3, it's going to add to the 4th thing. So that's the same concept. Okay, so now we need to add another function for a specific location. So we know we're going to have a parameter of location, and we're going to have a null, okay, with parameters with an integer and a parameter with a string. And we have another one that remove strings. Remove the function will be followed by a string inside the bracket. Everything. Okay. Remove. Okay. Yes. This is probably gonna be the hardest part because it tells you it wants to remove every sentence that contains the string, and any part of the sentence will get removed. So it says this will remove every single sentence with the letter A in. So will be hard because you have to create a loop that will go through every single sentence and check if A has it. And this would be different if it just tells you to remove like a specific node. So let's say that would have been completely different if it said, oh, remove node 4. That would have been way easier than what this is asking us, because we have to reconnect the nodes after you delete it so it can still go through the loop. So we're going to leave this function at the end because adding is not that hard compared to removing, and so is sort. Because see, you can tell sort alphabetically length. The sort command will be followed by a word alphabetically or length inside of parentheses. This will sort the entire list either alphabetically or by length. Okay, so basically we already have this function, which is right here, alphabetically and length. So we killed 2 birds with 1 stone with this. We have this already done. So we just have to worry about adding and removing. Adding and removing. Okay. So let's start with adding first. Which is gonna look, this is the adding one. It's gonna be the adding function and the remove function. We're gonna delete duplicate at the very end, and then also I made a function called unsorted. Why did I create a function named unsorted? Don't worry about it. Let's not worry about that right now. So okay, we're gonna worry about the add and the remove. So let's start with the adding one. So okay, void. So dumb. Void. English. Add. Just add. Oh, is that the one I named it? What did I name? Oh yeah, add. Okay. Add string. And then we have int. Post. Okay. Okay. So for adding, we're gonna do this almost the same concept for the first part as the sorting ones. We're going to create a node that tracks the current, and we're gonna have another node that tracks the previous. So we're gonna name current equals head, and have a node equals previous. So we have one that will check the current one and the previous. Two nodes at the same time will be ahead of the other. So, but this goes through the linked list, but it's telling us to add a node as well. So we also create another node that will be adding it. So say let's call it new node, the same thing. New node equals new node. See, same thing. This will store this. That's why we put that parameter. So command line. Okay. Now we have the node we want to add, and we have the other nodes that will go through the linked list. So, okay. So they give us a hint already. So let's say if the position is 0, this will be added to the beginning of the list. So it's saying that if the list was empty, it will still get added. So even if we don't have to check if it's empty, because we only need to know the position for this part. So if the position equals 0, right? We're actually just going to add it to the front, to the very front. This is all. We're actually going to use one of these functions. We said to the front function, because this already adds it to the very front. So this one is going to do the work for us. It's going to check if it's empty. It's going to check, so it's going to have a head equals to the new node, and we'll have new node, next, and so on. So we basically, yeah. So that's what that's only for 0. This is the only exception. So we literally just have to add it to the front of the list. Add it to the front, and we store the command. And then we want to return it so we don't have to do the rest. So we stop everything else. This is only if, remember, I want to make this clear because we can only do this because the position is 0. And we can use this function because it's already added to the front. It says added to the beginning of your list. So we already have a beginning, so we might as well use that function. So that's why I use this. This is only if it's 0. And then we want to return it because we don't want to do anything underneath this part of the addition. So right here, it's gonna we usually start doing a while loop and so on, but for this one, since we have a position, we actually have a certain position we actually want to stop at. Okay, we actually have a position we actually want to stop at. So we don't really have to go through the whole list. So that's what we just say for ints regular, ints 0, and we have I regular post I plus okay for the position. See, we want to stop before we hit the position. We're gonna treat it like a kind of like an array. So we start 0, and the position we're adding, we're not actually going to stop at that position. We're going to start a little bit before that. So let's say this is 5, I will be 4. That will be the actual position. And in the linked list, it will actually be the 5th position. So that's why we start at 0 and then we're not stopping at the very position. Yeah, that was a little tricky, but yeah. So let's say if cur equals no. So this is why the reason I'm saying if the current no equals no PTR, I'm gonna say that because what if the position is greater than the actual list itself? So if it's greater, then we cannot add it. We cannot add it. So we want to return. We want to exit and just not. We don't add it because the position is out of bounds. So I can't add the function. That's why I did this part. You want to check because right here it also said add 3. This will be added to your 3rd index, meaning it will be the 4th thing on your list. Won't get added if your list size is 2. So if the position is greater than the amount of nodes you have in the list, it won't be added. However, let's say you have 4 nodes and the position is 5, right? You could add it because there's 4 nodes, but it wants you to position 5, which means you want to add it to the end. So you could do that, but that's why we said less than, because we want to stop right before the position will be null. So it will actually be able to add it if there's 4 nodes and there's the position is 5. That because this will stop right before it exceeds the position. That's why we do this. We start at 0, not at 1, or put equals. Okay, now this is what we do. We want to put previous equals cur, and we have cur now equals cur next. This iterates through the list. This is it. This is pretty much it, because now we know what nodes we have. We have what nodes we have. So basically, we're gonna I'm gonna make a little picture. We have previous. So now, and we have current. Alright, previous and current. And then we want the previous next to now equal to the new node. Right? Because previous next we want it to point to new node, and we want the new node to point to the current. Okay? And then that's why, yes, so that's what we created too, because we want the previous node to point to new node, we want new node next to point to the current address. So this is how it's going to look like. So previous next now points to new node, and we want new node now points, my bad, new node next equals current. Yeah. So now new node next points to the current address. So now we have now, since previous node points to the new next, new node has to point to the current. See? Now we've done that. We completed this part. We completed this add function. To be followed by an integer. See? We added the position. So now we're gonna go to the remove function. The remove function, I'm not going to lie, gave me the most trouble out of all the functions. It gave me a real big trouble, so hopefully I can explain it well, but I apologize if y'all don't understand me. So it wants to remove, say, whatever what did I put here? String letter. String letter. Okay. So same we do not the same concept. No, completely different. We have node, but we're gonna iterate through the whole thing again. So we gotta go ahead. We have node previous equals node set to PLTR, and then okay. Now we want to start by going through the whole list. So we gonna say, like, how do we start it off? We say while cur does not equal no PTR, then we can go through the list. So it's gonna stop at the very end of the list. This makes us, so now this is where if we have to check. Now we check if cur. So you see how before I had to, like, they say, where's the for loop? Like in this for loop, as soon as I started going through the traversing through the list, I said previous equals current and current next. We don't want to do that right now. We don't want to do that. We actually want to check, because if we do that, then it will end up messing up, because we want to be able to check the very first node, because we have to check the first node always. So that's why we start with current. So we have if current line finds the letter, okay, finds the letter, and does not equals mpost. Mpost means it doesn't exist. So if it doesn't exist, so if this shit doesn't, if it says doesn't exist, okay, so if it says equals, if this is, we say equal, it means it doesn't exist. But say not, then it means it exists. So if we exist, we want the head to now equals head next. I'll explain why. No. My bad. I made a mistake. I forgot. We have to do something else. So now we have to check if cur equals head. Okay. we ask ourselves if it equals head because this will determine if it's the very first node. That's what because last time I told you we had to check if it's the first node. So if it's the first node, we want the head to skip over it. So now the head will point to that. Now the head's new address will now equals head's next. So it skips over the first node right here. So they'll skip over the first node and then we delete cur. So now the head will skip over the first node. That's why we said cur equals head, because this will be if it's the first node. So head will skip over. So you see. So let's say if cur equals head, it's gonna be like this. It's gonna be head, and then it will point. Oh no, what happened? No. Okay, head will point cur. So if that's true, then we want the head, and then we have. So now the head will now skip over cur because head and cur are the same, so it's gonna skip over it and then move on to the next. And then we want the now cur to now equal the new head. Oh no, my brain is down. I don't know. I see this right here is the same as iterating through the list. It will be the same as cur equals cur next. But since it's the first node, we can't really say cur equals cur next. It wouldn't make any sense because when we delete cur, we can't really set up cur equals to cur again. So that's what we have to check only the first node at first. So now we do else. If it's not the first node, so if cur does not equal head, it won't be the first node anymore. So now we have previous next. So let's say line 3, right? So we want to break the links. So previous next 3 between line 3 will be, let's say node 3 will be between node 2 and node 4. We want node 4 next, because next it will point no longer to 3. We want it to point to node 4. So previous next will have to point to cur next. Okay? If it points to cur, it will make no difference because previous next already equals to current. But we want it to point to the skip over it. We want it to skip over it, so we have to say next. We want it to skip over it, so we want it to go next. So now previous does no longer have a link. So that node 2 does no longer have a link to node 3. It points to node 4. But now we delete cur. We delete cur. And now cur next. Cur now equals to previous next. Why does the current address now equal to previous next? Because we deleted current, it no longer has an address. So we need to implement a new address. So because we deleted it, so we have to. That's why this is kind of like a temporary value. Yeah. So now this stores it back, makes it able to keep on going without breaking it. The link. This is where I had the most trouble. This part right here. This part, cause I didn't know you have to. So after you delete the current, I didn't know that has to make the current, we have to put it back to its original address. So now current now equals to the new address that was broken. Okay, so delete it. So yeah. Okay, now here's the part where it was even worse. So now once you remove that node, right? What do? We want to keep going through the loop. We want to keep going through the loop. So through the list, not the loop, through the list. So now we have to. Wow, this was hard. I'm thinking. Okay. Okay. So let's say if it doesn't find it. Let's say if it doesn't. Okay. Let's say we go to a loop and it doesn't find the letter, right? If it doesn't find the letter, then you just want to just continue going through the list. So you use the previous equals cur and cur equals cur. Previous equals cur equals cur next. Okay. See, now it checks the first node. We want to check the first node. If it has the letter, then the head will skip over the first node. And then we want to delete the current node. And then we want to go cur. We want it to point back to the head. So now the first node is no longer available. Here, if it's not the first node, we want the previous next to point not to the current node, but to the current next address. So it'll be, just say 2, 3, 4. 2 will point to 4, and then 3 will be deleted. But now we don't have cur, so we wanted to replace the address again. And then if it doesn't, then you just go through the linked list. So now we have all of these. Now we're gonna do a few more functions. We're gonna say delete duplicates, and we're gonna print. Okay? We're gonna delete duplicates and we're gonna print it. The printing I'm not gonna go over because it's just printing so I can make sure it works. And delete duplicate we need it because it actually tells us we don't want it to have duplicates. So I'm gonna go over the duplicate ones. Let's see. Say void delete duplicates. No parameter because you're just changing the we're just changing the what's it called, the list. Okay, create node, create cur equals head again. We don't want to create pre because we're not really looking at the previous one, even though it will make sense. But you'll see why in a minute. So we create a while loop, we go through the list again, but this time will be different. Because my workshop professor told me that for this one, we want to make sure the current address and the current next address don't equal to null. Because we're going to be traversing through it. Because we're going to be comparing two at the same time. Two addresses, we're going to be comparing current and the current next all the time. So we don't want neither of them to be null because they wouldn't make any sense. It will create a memory leak, I believe. I think that's what it's called. So if cur, say line, cur line equals cur next line see, you see how we this and this let's say we have 2, 3, 4 nodes. So we're checking the node 2 and we're checking node 3 data at the same time. So this is what we're gonna do. If they equal to each other, it means that it has a duplicate, right? So so what we have to do is create a temporary value, a temporary node, my bad, that will equals to the current. We want to delete the next one, this one. So we're gonna create cur. I don't think it will matter which one you delete, but I'm gonna do the next one because it makes more sense to me. But see, okay, no, actually, no, yeah, no, it does matter. We have to equal it to current next. You'll see why, because it's the same thing as removing it. We want it to go. So we want the current to now point. So we want current next, not current next. Yeah, current next to now point over the duplicate. So it'll be temp next. These are not the same. Okay? These are not the same because temp next is basically 2 nodes ahead of this current. So that's what it will make it skip over the node. And now we can easily delete the node because it skips over it. It removes the link from it. Not removes the link, not deleting temp removes the link from it. Well, technically. So now it deletes it. And then that right there takes care of the duplicate. So let's say if there's no duplicate, we just keep going through the list. Equals cur. Okay. Okay, that's pretty much what the duplicate does. Duplicate function does. Okay, so now let's see. We have duplicate. Okay, now I believe we're done with that part. We're done with is something. I have an unsort function here. I forgot what I did with it. But we're gonna go to the main function now. Alright. So we're gonna start the main function now. We're gonna do the main function. So we already completed the list, right? We completed the linked list. So now we're gonna actually read the whole input, the input file, and then the command file. So for the input file, we're gonna actually want to. We're gonna have I made a string called alphabetically and a length called length beginning and because in the examples that you gave us, this alphabetical part, the first line will tell us how to sort it, how they want us to have the list. So this one has an alphabetical, and then this one's the length, and this one's the beginning, and so on. So that's why to make it simpler when we read it. And then we have string temp because it's I always use temp because it's gonna be useful throughout the thing. So let's see. Wow, get line, anyone input. I'm sorry, I cannot type. And then we have input line. Okay. Now so we gotta say first. There's gonna be a lot of if statement. I'm telling you that right now. If input line, we gotta check input line equals nothing. If it's an empty line, we do not want to add that to the list. So we're gonna press continue. We're gonna continue means we don't we read the code and we just start the loop again. Basically, we exit out the loop and start a new one. So we don't want this. Will skip the empty line. This will take care of the empty lines. So now we gotta take care of the first line because it's going to determine how they want us to sort it or how they want us to add it. So if input line equals alpha, which I have it as, or input line equals length, or input line equals begin, or input line right, we want, there you go, see, this is where temp will go into. Temp we want now to equal input line. It will store the line. It will store the first line. So we don't want to actually add the first line to the input file at all. So we're gonna, after we store it into the temp, we wanna exit out the while loop and continue to the following loop. So now let's say if temp equals so now we don't actually want to sort it because it wouldn't even make sense. So first we're gonna deal with how they want us to add it. So we're just gonna focus on begin. When we gotta add it to the beginning. So when we want it to begin, I actually forgot a very main thing. I forgot something very crucial. First we're gonna create our linked list. We're gonna call it list L. Right? So my bad. So we want to list L, we want to add it to the front. And right here, what we do, just put input line. And then our linked list class structure, we'll just add it to the linked list, to the front. Now let's say else if temp equals n. What we do, just say list, we add it to the end, add to the end, input line. So we just add it to the end. Oh, okay, that's what I was missing. Okay, so let's say if it's alpha length or beginning, because we still gotta store if it doesn't say either one of them. That's okay. So if it doesn't say, we could make another function called unsorted and just copy, but we're not gonna do that. Because we're just gonna say list. So this part, actually we do. Okay. We could, okay. Afterwards we can continue it, so it'll exit out. Okay. Okay, yes, okay. Because if it's temp equals temp alpha or length, we still wanna add it to something. So we still wanna add it to something. So we're just gonna add it to the end or something. Input, yeah. Because you'll see why. So we're just gonna, so if temp equals begin, what isn't it? So if it's begin or end, it's never gonna go through here, so it's not gonna add it twice. So it's never gonna add it twice because we have to continue. It's gonna skip this part, so that's why. Yeah. So yeah. So let me close the file now. Import. I close the file. So I close the file. Now we have the part where if it has beginning or it has end, we took care of it. But now we want to sort it. We want to sort depending if it says so. If temp equals alpha, then you just want to list the alpha sort. Else, if temp equals length, we just want to list L dot length sort. Okay, there you go. This will sort the whole list. This if it wants us to sort it by alpha or by length. Again, that's why we need this, cause if we didn't have, cause if it had temp as alpha, we still want to add it to something. We just don't want to have, like, if we didn't have anything, it wouldn't never add anything, cause temp will freaking be alpha or something. So temp, because it's gonna skip over all of these and it's gonna go through here. So then right here, so now we have everything. We have everything done for input file. Everything has been done for input file. Now we go to the command file. The command file is a lot. You gotta probably, because there's gonna be a lot of substrings. I'm laying up right now. So we're gonna have string. So we're gonna have almost the same thing. Let's see. That way I did it might be. See, we gotta take care. There's gonna be a lot of substring. You'll see what I'm talking about. We actually have to add position, because for the adding function to what position, and then because we want to self-sync through a lot of things, we're gonna have a lot of string temps. So we have temp 1, temp 2, temp 3, temp. I think this. And let's say temp 4. If we don't need, we just come and erase them later. Oh, I forgot temp 2. Temp 2. Okay. So we go now. Okay. Now we go and go through the command file rules, like while line command and command line. This goes to the command line, and now this is where there's going to be a lot of things. So this is what we do. If the command line finds the add that we use right here, if it finds it, which is going to be like this, string and post. Remember, this means if it finds it. If it finds it, this is what we're going to do. We're going to have temp1 equals the command line, right? And because we're gonna erase the command line. because we want to extract the data from it. We want to extract, let me see, where was it? We want to extract the location, and we want to extract the sentence. So the only way to do that is to erase and substring. So we're going to erase the command line. We're going to erase from command line dot find from position where the last parenthesis is at. So right here. And so it's going to delete everything and onwards, I believe. And then oh my god, okay. And then we're gonna have yeah, so it's gonna erase everything from that onward. Oh, so it's gonna erase, so we're just gonna have this part. We're just gonna have this part from here to here. We don't have this anymore because we want to store the position, the add position. We're gonna put store because that converts a string to an integer. We're gonna store command line dot sub string, which is gonna be command line dot find okay, right here it's gonna it's this is the number. It's gonna go from here, just the number. It skips the parentheses and it goes all the way up to here. But since this part is erased, we don't need it. We don't have. That's why we erased it, because we need to come. And you see, this is why I stored it. This is why I stored temp1, because we're gonna have to erase it. We still gotta store the string, right? So now we use temp1 dot erase. We're gonna erase almost the same from we're gonna erase from not add. What am I talking about? We're gonna erase from temp1 dot from the end of it -1. This is gonna delete the bracket, right? This will delete the bracket, and we're actually gonna have temp1 now equals temp1 dot no, we use another temp. We want temp2 now equals temp1 substring we gotta find the bracket, which will be temp1 dot find. I'm going a little overboard. Okay. So this will store the sentence. So now all we do is list L dot add, not add, yeah, it's add, literally add the, you're gonna add the position, which is temp2. We're gonna add the position, so add those right there. We took care of that part. So we took care of his add part. Now we take care once it sorts it. We take care if it sorts. If command line dot sort, command line equals sort, sort dot find sort exists. If it exists, we're gonna also erase. We do the same process actually. We just, yeah. So we have temp 3 now equals. We erase command line, erase. Show command line. I'm pretty sure. Fine. Let me see. We want to parentheses. From parentheses. Right? No, no. First we gotta take care of that. Command line. The end of it. Dot -1. There you go. Not all. Did I do -1 on this one? No. Is it +1? Of course. Oh, right here. Oh, I forgot to put -1 here. So yeah. So. I forgot to do something. I forgot to do something actually. Actually, give me a second. Okay, I'm sorry. I was wrong. Because I thought since I'm in a space here, I didn't have it right. Okay, yeah, that's my fault. Everything was right. Ignore what I said the last few minutes. So we erase the command line because we want to erase the bracket. Let me see. Okay, yeah. We want to erase the where is this? We want to erase the bracket basically, not a command. Let me see where is the sort. We want to erase the parentheses. Alright, we want to erase the parentheses. So we erase the parentheses, and then we store it again. So we store temp. This is 3 because we haven't used that. We store temp3 equals command line dot substring, and then we say where's this command dot find parentheses. There you go. +1. Okay, and then so now we just because this +1 because we don't want to include the parentheses. That's why we do the +1. So now we just add it. No, we sort it. Okay, no, no. My bad. So we hit a temp. Okay, because this is the story, so it's gonna we gotta check if it's alphabetically in that. So that's what we have to do. If temp3 equals alpha, which are the things we used last, the variable we used for the input file. Oh no, let's so C alpha. My bad. Come C alpha. We're gonna use list L dot alpha sort. Now we have if temp3 now equals C length file dot list L dot length sort. Okay. So now because temp3 now we have the word now we'll sort it bit depending whether it's alphabetical or length. So now we just need one more and then we're done. We're done with this command file. So the remove part, always the hardest. If it finds command line dot find remove string and I always mess up. Okay. We want to get we're gonna erase again, so we're gonna erase command line dot erase. We're gonna erase the bracket then. The thing is a bracket, so we're gonna erase the bracket then dot because we don't want to include that. Nice one. Alright. And let's see. Temp4 now equals command line. Oh my god. Command line dot substring. Because we want to set command from the parentheses and onwards. It's from 3 plus. Okay. Is it a bracket? Oh no, wait. No. I made a mistake. It's not a bracket. Yes, it is a bracket, but we have to find. We just want to erase just the bracket. So we just say following. There you go. We just erase the bracket if we find it. And then here, just that. And then, okay, this will allow it to only have the letter or string or whatever stored. So now all we have to do, let's see, list L dot remove temp4. And we should be done. But don't forget, at the very beginning we have to say we want to delete the duplicates. So now all we have to do is delete list ll dot delete duplicates. We will delete the duplicate. To make sure it works, we're going to make a print function. That's why I have it here. We have it offstream, so I'll put it. I'm just going to, it's almost the same. I'm gonna copy from my actual homework because So basically, you just void it and then print or something, and then let me see. Okay, boom. And yeah, so let's test that out. Let's see if it even works first. This dot print. This ain't no mistake for me. Okay, no mistake for me. Yeah, we don't have apples, but we can test if the test is work. Test 2 sh test 2.sh. Oh wow. Okay, so I failed some and I do not know why. Let me check. Let me get back to y'all. Let me get back. Okay, I'm back. Oh, okay, so basically the reason was failing because the answer, they didn't have the answer file, so that's why I said didn't check them. So if I test it again, test 2 sh, it should work because I got the file. There you go. See, it works. We got the file. We got what we wanted. Oh, well, there you go. Thank you for watching and have a good day.